From ContainerDays Hamburg, this video is proudly presented by Dux IT.
Hello, ContainerDays. As I've already been announced, my name is Andrii, and today we will talk about how we build multi-arch containers. Yeah, a bit myself. It's more like repeating what I already talked. I'm a full-time developer. Not my tech evangelist is an extra role, so I do coding daily, 90% of time. And yeah, I'm presenting Dynatrace. My team and our team is responsible for implementing Dynatrace operator. Why it's matter, not a selling point, just it's open source project, and we build images for multi architecture containers. That's why this kind of can be interesting. So yeah, and thanks for coming for my talk. I know it's was busy 3 days, and yeah, you're doing well. Cool. So, have you ever seen this error? Just raise a hand. Nice, just my audience. So this error message usually on your Kubernetes cluster while we're running any container, maybe locally. So yeah, we will talk about it today. So quick demo. So when we run something like Alpine using Podman, and just most probably we will see this error because Podman telling us something. Podman is smart enough locally that, oh, we are running wrong platform. But when we use Kubernetes, yeah, if you're curious why I run images so strangely with SHA, it's just because I would like to reproduce it. Otherwise, Podman is smart enough to pull right image, but I intentionally trying to break it, as I usually try to break stuff until make it work. And Kubernetes is not smart enough. It just shows you crash loop. And if you try to get logs, you will see this very cryptic error message with like, what does it mean? And yeah, so, and today we will go deeper how to solve it and how to prevent it. But quick recall, as a default setup for our team, maybe majority of other developers nowadays is that you have a kind of a Mac or something which use ARM. And yeah, of course you can ask different processor or different laptop, but most likely your server is still using AMD or something like it. And this is like where two worlds conflict, because I would like to build my project locally and I would like to test it locally. It works. But when I would like to test it on a different cluster, I have a problem how to make it work. So let's talk a little bit about single platform image. What does it mean? So I have a simple Docker file or container file. Quick note, today I will mix maybe a little bit Docker files and container files, Podman and Docker and other tools, just because we don't use something, we don't use specific, we just try to be abstract, but we'll work with both. So you can see I have this Alpine Docker file, which has one line. Show me your architecture, and I pipe it to the file. I build it, and when I run it, yeah, assuming I'm using Linux machine, for example, with Podman and with proper chip, not ARM, you will see this, so it works. So what we just did behind the scenes, it's what Podman did, or Docker can do the same. When it builds an image locally, it's used host architecture where you run Podman engine or like Docker engine. And so it's smart enough to figure out and build everything. In the world of when every architecture is equivalent, we don't have any problems. But unfortunately, it's not where we live right now. So what is this mutli-arch image? Raise a hand if you don't know what does it mean. Don't be shy. Okay, nice. A few people don't know. So even if you think you know, I still believe you're not fully aware of what does it mean. Just it's how I thought about myself. So originally I also thought I know what it is, but in practice it's a little bit more complicated. So long story shortly, Docker, originally we started using containers using Docker, has this concept of these multi-architecture containers, which means that single Docker image tag, it's important, can support multiply architecture. So here's an example. If you have Docker file with like from Golang 125, we don't specify architecture, right? But Golang image tag 125, it hides different images under this tag. So when I say different, it means different operation system, processor architectures, so different images. And yeah. So, and in practice, this specific image includes more than one architecture. It has ARM and AMD and even different variations of ARM, like V7, etc. So under the hood, and if you go into specification of open containers, I highly recommend to review it. So single platform image is just a manifest with layers, or it's like a JSON file and a specification defined for let's say container runtimes implementers, what needs to be done to make something an image instead of just bunch of files and JSON files. And yeah, and it has config. But when we say multi-platform image, it's a little bit different. It has like an index of few manifests. So it's kind of a container of other subsets. And if we try to inspect Golang, yeah, I already filtered a bunch of redundant output. And if we print only platforms, you can see that this specific image consists different architecture and different flavors. And again, I will repeat myself, when Podman or Docker or whatever pulls the image, it's always used by default if you not specify explicitly the architecture of the host where you plan to run it. But recent raise of ARM, yeah, I stole this picture from this nice blog post. So we see really huge increasing in ARM's processors, and which means servers running on ARM are already kind of trying to beat servers running on AMD. And I know that our customers also moving to ARM. It's out of scope of this talk. You can read in this article or just Google. ARMS has some benefits in pricing, in even environment, safety, etc. But today we will talk about kind of our problem. So there was like introduction, so you kind of understand what I will talk next. Originally, my team, we use Docker. And as probably all of you know, Docker changed the license for Docker Desktop, and we were like, okay, we build open source project, we can't use Docker anymore. We need to try use Podman locally. So we decided to switch to it. So, and yeah, we just follow traditional approach. We build like each architecture on different machine, and you push it to the registry. And yeah, so what we did, we mostly replaced Docker with Podman. Thanks to Podman, they mostly emulate majority of the features of Docker and even semantics of usability. That was really nice. And second, you just build, for example, ARM separately and you push it. So for each architecture, you have to build and push image independently. And then what we do, we can combine them into one single manifest. Remember I show you that manifest has like pieces. So you do it here. First you create manifest. Yeah, it looks a little bit weird, but you have to get used to it. So first parameter is manifest name, but for user of your image, it will be final what you usually pull. And then you provide sub multi-architect images you just built, and it will put all together. And then you, instead of push image, you push manifest to your registry. That's what we did. We replace everything with Podman. We try it locally. It works. We did something similar to with Docker. And then kind of it just works on my machine, right? It worked on my machine, but it did not work on CI. It did not work on production. And we're like, why? I mean, easy peasy, job is done, no? We can, but the problem is that on CI, what we found that Ubuntu runners has different Podman versions than we have locally. And you're a little bit limited about Ubuntu version, and you know this how Ubuntu has LTS, and if a package has already installed, it's a bit tricky to upgrade it. So, and Podman was already pre-installed, and you can't just bump version. I mean, you can, but it's lots of work. Then we realize it's not like 100% feature, and second, we try to optimize steps. So we build independently architectures. And what we did, we share images between jobs, but this Docker load and Podman load works differently when you try to export image without pushing it. So we decided, okay, we need to go deeper, right? We need to investigate. Maybe we're doing something wrong. And we found that, like, okay, Podman has something like Docker Buildah. It's like extension of the Docker, I think. You can just specify platforms you need, and job is done. And yeah, if you go and push it, you can see that, for example, Docker Hub can show you, can show you which architecture you just pushed, or like which image are you using. So and next, someone like, okay, how it works under the hood, same as Docker, but we realize it use Camu. And if someone not aware, Camu emulates the architecture that don't match your host machine. So Podman, when you try to build, it's not about Podman. It's like when you want to build multi-architecture image on your host machine, which supports one architecture, it will use Camu to emulate it, so you can build other architectures. Unfortunately, Camu is very slow, or at least slower than if you use native architecture. And if your Docker file or if your project is pretty simple, I mean, it's okay, it will be super quick. But in our case, it was like not always the case. So we tried this, and this one worked. But then we're like, okay, we need image annotation and labels. Who's using image annotations? Raise a hand. Okay, not many. I will tell you why you need it. Image annotations is like also easy peasy, right? You can annotate something and then it can provide you descriptive metadata of your images. Of course, you can skip it, but for some security and other constraints, like for example, if you deploy to Google, how it's called, I forget, whatever. So if you deploy your image to some Play Markets, they have security constraints, so they force you to annotate your image in special fashion. So you must annotate, so it like prevents some security whatever attacks, so they know it's your image, kind of. And yeah, as I told you, just metadata for images. They are similar to labels, and they can overlap. They serve the same purpose, as I told you. It's like I already mentioned the OCI image spec. It defines a format, but unfortunately there are still different media types. I will show you a little bit in this. So if you check the line number 2, there is like a media type version, and when you try to investigate something, you need to figure out, okay, is a media type version the same I want? So so we struggled with Podman because Podman struggled with annotations, and only in version 5, I think. Yeah, here I'm adding like, and also you can add different levels of annotations. So you can annotate entire manifest or like entire index, or you can annotate per platform, let's call it, like per image. So, and then, yeah, so like different layers. So how I did it, you just build an image, create manifest, and then you have to annotate it. So it will be top level annotation. Then you add your image, and you have to annotate this image when you add it to manifest. So that's only way you can add annotation. And then if you inspect it, you will see my annotations, kind of. But what we struggled again, it works only with Podman version 5, because we started Podman 3 plus, then we upgraded to 4, and majority of what I just showed, you have the most recent Podman version. If you try older versions, it most likely has some random bugs. We spend much of hours to debug, but yeah, here it is. So yeah, it's a little bit of my lab setup. I don't know if you would like to try it out, and we can just skip it. So next problem, okay, we annotated, we have image, we build image. I know it sounds boring to me either. And the last step before we go to production, you usually promote images to registry, right? Just push somewhere. And this also sounds easy, but the problem is this copying images around sometimes break either annotations, or you have to recreate images. So for example, what we tried, if you already have an image and you push it somewhere, you can use nice tool, open source Scopio, which will kind of copy it. Otherwise, if you don't want to use third-party tools, you have to do something like it. Yeah, it's a big bash script we wrote. You can reuse it. But most important line is a bottom. So you have to pull image, specific architecture, again create manifest, and again push, which is not good because you will kind of change manifest because you create manifest for each registry you have. So if you sign your image, so to prevent supply attack chain, it's not good. So we're mostly doing it for local development. And probably last but not least was, okay, it's super slow because some images we have must compile OpenSSL. And when you do this goofy stuff with Camu emulation, it will take like 2 hours probably. So we decided, okay, maybe we need to use parallel builds. And like Podman does not support parallel builds in any way. So again, I just repeat myself. You build images, list of platforms, and you push it. So easy. What we want to do and what we should do, we want parallelize this kind of piece, platform, comma separated value. Of course, you can say, come on, it's super easy, yeah? I have a pseudocode, I mean, it's fake YAML, but it should work in some CI systems. So you build independently an image and you use this push to registry, and then separately you have to pull it and create manifest and combine. That's how you can prevent it. But the downside of this approach, you have to pull these images, which is also not super cheap and also slow, kind of. Then we realize, okay, there is this Buildah also tool from I think it's from Red Hat. So it supports this nice parallel build. So it's the same semantics as Podman. So just say, instead of Podman, you can just say Buildah build platforms. And if you specify parameter jobs, it will build everything in parallel, by default, one piece at a time. And again, we try it. It also has lots of bugs because Ubuntu has very old Buildah, and the way they release it in Ubuntu is a little bit slow. So then we moved, okay, beside it, how can we improve like our CD pipeline? Because if you go to CI/CD pipelines, we used mostly GitHub Actions because we are open source project, like everything you can see. And the first problem, Podman, there is no like a GitHub action for Podman. I know it's easy, you can just install it, but what would be nice if you have something from officially supported. So another problem was like, okay, we found Buildah GitHub action and it was pretty nice, but if you like read this red signature, it's like last release was like when? 4 years ago? And then I saw they make a release last year, so like one release in 3 years. I mean, it makes sense if your software is super stable and like ideal, but we like majority of bugs they fix in new versions of Buildah is kind of outside of this release cycle, so we kind of give up. and yeah, you can see the official. Someone asked about like, okay, where is a Podman? And the answer was, yeah, kind of we are not responsible for it, which is makes sense, and you just can install it, which helps, which puts us nowhere. So as a result, we a little bit give up. Like not every story finished with success story, right? So in the end of the day, locally right now, we still use Podman, and we believe that soonish we will migrate because we know everything we need, and the feature parity is already kind of close. But we still build production images on CI using Docker build push action, which is the most stable right now and testable, and there is no equivalent one, unfortunately. But soonish we can make our own, I think. And we will switch as soon as we can have upgraded runners. Yeah, I know you're all tired, so I will be quick. So conclusion. So easy path, not always easy. What we learned that you have to try everything locally, because the amount of issues we found, and I not even put it to slides, is insane. But because we all use Podman locally right now, and I believe that people start using it more after license changing, it becomes more like stable and feature-proofed, etc. So highly recommend you start using it, report a bug, and we will all kind of win from it. Yeah, another problem that if something written in specification does not mean implementation of it is like 100% equivalent. So make sure that it fits. Because in our case, we had we struggled a lot, especially of annotating specific pieces of metadata, and it just didn't work. Yeah, again, if you read something, try it out. There are a few links you can read. I share slides. Yeah. And questions.
From ContainerDays Hamburg, this video is proudly presented by DuxIT.